Hey everyone, this is Carlos Bassi. I apologize for we had a few technical difficulties, but Jess is ready to go. I'm going to run through uh, I'm going to run through my slide deck really quickly here, and then hopefully we'll get Jess on here in a minute. So, welcome to the Past Performance Virtual Chapter. I'm the moderator. My name is Carlos Bassi. I'm also the president of the chapter. You see that we have several ways you can reach us and get in touch with us and join our group, so please do so. The main technical assistance I will tell you is that you have to listen through your computer speakers. There's no other audio option, including phone, and the session is being recorded. We get that question a lot, and we will post it on YouTube afterwards. There's a lot of virtual chapters, so please join ones that you're interested in, anywhere from other languages such as Russian and Spanish to security and cloud, and we're one of many, so please participate in any other ones that you are interested in. Remember that the PASS Summit is coming up in November 6th through November 9th. Jess is a speaker at the summit, as I am as well, so we're glad to have Jess, one of the top people in her field, to speak here for our group. And remember to use our discount code VGDIS615Q and get $150 off the registration price if you're still interested in going to the summit and going to register now. Remember that PASS is always looking for volunteers. It's a volunteer-run organization, and so go to volunteer.sequelpass.org if you want to get involved in speaking, helping put on sessions, or organizing events. The PASS is also free. The membership to PASS, if you're not a member, and there's many ways to find PASS, but go to www.sequelpass.org, and that's the main website where you can find all the information. Next month, or next week, actually, we have two sessions back to back here. We have Performance Tuning Azure SQL Data Warehouse by Warner Chavez. Warner's great. He's been with us before, really knowledgeable. I'm really looking forward to that session. So please tune in next week. And then today we have Jess Borland, reporting and analysis in your transactional database. You can run reports in production, and Jess is one of the top people in the SQL Server database world as far as performance is concerned, indexing, and running high volume SQL databases. So I will turn it over to Jess and let her share her screen, and we'll go from there. Thank you very much.
Excellent. Thank you, Carlos. Let's see, show my screen. Are we set? Can you see my slides?
Yeah, we can see your screen now, Jess.
All right, perfect. Now, which monitor are you seeing?
I'm saying the preview, actually.
All right, switch that over. I haven't used GoToWebinar in a while. So, all right, good afternoon or good morning. Thank you, everyone, for bearing with me with some technical difficulties. Just proving that even if you have presented 100,000 times before, stuff happens. But here I am, and I am happy to talk with you for a bit about running reports in production. So thank you, Carlos, for the introduction. For those of you that don't know me, my name is Jess Borland. I hail from Wisconsin. I'm a premier field engineer specializing in SQL Server at Microsoft. My contact information is here. So if you have questions about stuff I talked to today, feel free to email me, feel free to tweet me, and check out my blog as well on lessthan.com. That picture is me at one of my many running races with my favorite dog in the whole world, Jack, who also has his own Twitter account. So let's get on to, I could talk about my dog for an hour, but I will talk about what you really came here to hear, which is all of your users are probably banging down the door saying, I think it's great that I can get this report with day-old data. But you know what would be even better is if I could see today's data, or if I could see up to the minute data. Or even better, as I've encountered many times, you have a system where when it was first built and it was small and not a ton of people were using it, you did let users run reports against it. and they got used to seeing up to the minute data. And now the system's grown. The data's gotten larger, the amount of users has increased, and with that, performance has decreased. You tell the users you're considering moving them to a system in which maybe they don't run reports on live data and they panic. That's not acceptable either. So, what are some options that you have to allow your users to do analysis and read data from a transactional database in which your application is doing inserts, updates, and deletes with minimal impact? Well, we're going to talk about several strategies today. I'm going to focus on 3 main tools because there are a ton in SQL Server. For the next 45 minutes or so, I'm going to talk about how we can use indexes to help speed up any type of query in our system, how we can change isolation levels to change the behavior of writes and reads and how they conflict. And I will also talk about using availability groups and the availability of secondary replicas to run reports as well. So let's talk about indexes and the current state of indexes within SQL Server. The basics. So let's go back to the beginning and start with row store indexes, or the typical indexes that you think of when you think about indexing a table in SQL Server. A row store index is what we would call just a traditional index or a B-tree index. The row store index has a row of data stored on an 8 kilobyte page. With that, we have 2 different primary types of indexes that we can build. A clustered index is the table, right? You can either have a heap or a clustered index. A clustered index has all of the data, all of the columns, and all of the rows. Sometimes SQL Server will perform, clustered index scans in which it reads all of the data from that table. On small tables, maybe not a big deal. On larger tables, probably not ideal. So what do we do to help alleviate that? Well, we create non-clustered indexes on our tables. Non-clustered indexes allow us to store a subset of the columns and all of the rows. Non-clustered indexes you can think of as skinnier versions of our table. This helps us go from using a clustered index scan or a clustered index seek, not jamming through all of my slides suddenly. Oh no, you're getting a preview. Okay, non-clustered indexes can help alleviate the pain of reading all of the columns, but still have all of the rows. So another thing that we can do to finesse that down a little bit is add filtered non-clustered indexes. These are going to store a subset of the columns and a subset of the rows. So let's take a look at what this looks like. If we kind of envision a table of data and rows, here, let's say we have a table that has order tracking. So we have our ID column, we have our sales order, probably a foreign key, and then we have a tracking number and a status. So if we consider a clustered index, it's all of the columns and all of the rows. The larger the table gets, the bigger this clustered index gets, the more rows we need to read. But let's say that what we really care to do is run some queries against what our carrier tracking number is. We want to know when a specific, a user wants to track their shipment. We create a non-clustered index on carrier tracking number. You'll see we have a subset of the rows, but it's a subset of the columns, but it still has all of the rows. With this in mind, though, you'll note I said I was going to create a non-clustered index on the carrier tracking number column. Why does it have the order tracking ID? Well, the order tracking ID is your clustered index key. Note that clustered index key always stored on non-clustered indexes because it helps or it ties back that each row to the main clustered index for various operations. But what if this, as it grows larger and larger, is still too much? Well, we can create filtered non-clustered indexes. So you're familiar, create non-clustered index on, then you add your table name, and then you add your key columns. You can add a where clause to that. Here, I added a where clause for a specific carrier tracking number. And you'll note that now I have a subset of the columns and a subset of the rows. What does this do for us? Well, non-clustered indexes are going to take up fewer pages on disk than a clustered index. That means that when we read that data, it requires fewer reads. Rather than having to read 100,000 pages on disk, we now only have to read 50,000. It's a 50% I/O savings. That means that our queries can return data faster. So regular indexing, just taking a look at how is our query actually reading that data, what indexes already exist, and what are possible missing index recommendations or missing index usage is still where I start with query tuning every single time. Are there some drawbacks to row store indexes? Sure. The more non-clustered indexes you have on the same table, the more storage space that will take up. The more non-clustered indexes you have on a table, when you do inserts, deletes, and possibly updates, that can increase the number of writes that you have to do. In that previous example that I had shown you, if we need to update a status in this, for example, in this example, it would only affect the clustered index, but state that this non-clustered index contained carrier tracking number and status. If I needed to update everything that was in a 1 to a 2, I would now have to make writes to both the clustered index and the non-clustered index. So be aware of too many non-clustered indexes on a table. And also keep in mind that the larger your tables get, the more rows that there are in the clustered index, the more rows there are going to be in a non-clustered index. And that can still have a potentially large impact on filtered non-clustered indexes. So let's just go ahead and do a quick demo here. I am going to use a couple of performance tuning tools that I always use, such as include actual execution plan and setting statistics I/O on to prove how much and what type of work is my system doing. So in this case, I am going to look at the big product table that I have. I want to look at products where the size is not null. When I run this, you'll see it takes a couple seconds, returns about 10,000 rows. When I look at my messages tab, I see that I have done 603 logical reads. If I look at my execution plan, pretty basic shape here, but it's a clustered index scan. So it's reading that index on disk that has all of the columns and all of the rows. You'll notice if I look at that, then the cost is about a 0.475. Let's change this up. Create a non-clustered index, what I would call a covering index. It's going to have size as a key column because that's in the where clause, and I'm going to include the columns that are in the select statement. When I do that and run the same query, I should still get back 10,551 rows, and indeed I do, but we've reduced our reads significantly down to 140. Our execution plan is the same shape, but we have a non-clustered index seek now instead of a clustered index, and our overall subtree cost has gone down as well from that 0.475 to a 0.099. So that is how a simple non-clustered index affects our I/O and query plans. What does that look like with a filtered index? Well, here's the syntax for it. Create non-clustered index. We give it our name. We give it our table name. We give it our key columns and our includes. And then, as I mentioned, it's a simple where clause, where size is not null. Create that. Now let's run this same query again. If I look at my execution plan, did it use it? Yes. So it has chosen to use the product size not null that I just created. You'll note here that our query cost has gone down even further to a 0.057. And while not significantly different, the amount of reads has gone down as well. So definitely take a look at filtered non-clustered indexes to help on larger tables. If you go out to my blog on lessthan.com, I've got some blog posts out there about filtered indexes and indexed views that might be helpful. So row store indexes have long been an arsenal in our SQL Server toolbox, but they start to hit some limits as tables get larger and larger and larger. So with that, we introduced the concept of column store indexes. Column store indexes aren't just another flavor of row store indexes. They are a completely different storage mechanism. They're a new way of storing data. So when you have a row of data, rather than every row having all of its columns stored on one 8K page, we now store every row of data in its own segment or in its own column, and then the rows are stored together as row groups. So there's a whole bunch of terminology around column store. If you haven't worked with it yet, you'll become familiar with having a column, having segments of columns, having a row group. That's how we tie together column 1 and column 3 and column 4 in a query. What's really important for you to understand is that column store works really well because it's much easier to compress data down when all of the value is an integer, or all of the values are a date time, or all of the values here are character fields. And with the new system that we introduced, we're achieving up to 10x compression. And again, much like row store indexes, if you can reduce the size of your indexes, it's much faster to read the data. Column store has taken that and made it significantly faster than row store. In addition to just the storage mechanism for column store indexes, we also introduced the concept of batch mode processing when getting data out of those column store indexes. Here, rather than sending rows across the wire, when you look at your execution plan, you'll see, a clustered index seek, and then you might see a nested loop join to another non-clustered index, and then that sends it to a compute scalar, and then that sends it off to the select statement. When we're dealing with row store indexes, those results are sent one at a time to the next operator. With column store indexes and the new engine, we can send those in batches of up to 900,000 rows. Plans mix row and batch mode, and this can really significantly reduce query execution time. So column store index is a combination of both the storage mechanism and the batch mode. So we have two types of column store indexes, just like row store. We introduced non-clustered column store indexes in SQL Server 2012. You would have your typical row store clustered index for your table. That's where all of your inserts, updates, deletes are written to. And then you would build a non-clustered column store index on top of that. Or introduced in 2014, we have clustered column store indexes. Much like clustered row store indexes, the index is still the data. I'm not going to spend a lot of time on this particular slide just because we started a little bit late. What I want to emphasize is that column store index really hits its stride in SQL Server 2016. With 2016, when you create a non-clustered column store index on top of a row store table, you no longer have to drop and recreate the index to refresh it. It updates along with the base table. Non-clustered, you can create the non-clustered on the clustered column store index. So when you have a clustered column store index, so all of the data is compressed, you can now create non-clustered row store indexes on top of that data. And column store now works with in-memory tables. So I typically tell people if they're looking to use column store and they can, either start in 2016 or upgrade to 2016, they'll get the best experience. The ideal workloads for column store. These aren't really designed to work with transactional queries. That's not what they're meant for. They were designed to solve this reporting in production, reporting on your transactional data, or working with data warehousing large data set queries. For select statements or reads, we're the best performance you can get with column store indexes as when you say, I need to select 20 rows and half of those are going to be massive aggregations. I'm going to average this and sum that and do a windowing function where I'm looking for ranking, and then I want to pull out this number and I want to aggregate that together, and I want to do it across 50 million rows or 500 million rows. That's where column store really shines. You don't want to search for one or two values in hundreds of millions or billions of rows. That's what a row store index would still be better for. As a matter of fact, with column store, it doesn't start the compression algorithm until you hit 1 million rows. I've had some customers that have been like, Jess, I created a column store in QA. I thought I'd really get this great savings benefit and performance, and it's not doing anything. Well, their QA environment has 10% of the rows that production does, so you can't really simulate it. So I often tell them, well, you're gonna have to double, triple, quadruple the size of that table in QA and then try it again. When we're talking about inserts, updates, and deletes, the fewer updates that happen to the column store, the better off the performance will be, just due to how we have to introduce inserts, updates, and deletes through this delta rows and internal stuff. But essentially, if you have a purely transactional table where you have a lot of inserts, updates, and deletes, and you want to run these reporting style queries against it, build a non-clustered column store index on top of it. If you have a truly data warehousing scenario where you maybe load data once a day, or even every few hours, but not on a regular basis, and you need to run these large reporting style queries against them frequently, a clustered column store index is a great way to make that happen. So let me take you through a couple demos using some column store indexes and show you what those are all about if you haven't seen them yet.
Hey, Jess, before you go there, can I just chime in? And normally we'll maybe take these pauses and ask some questions, but since we got started late, I'm just going to hold questions till the end.
Yes, that would be great. And I think GoToWebinar usually collects it all in like a Excel spreadsheet that I can reach out to people afterwards as well.
Sure. Yeah, okay. That works.
Okay. So thanks everyone for your patience. I am trying to end reasonably on time. We all have another meeting to get to. Isn't that the way of our lives? All right, so I'm looking at this table called Fact Reseller Sales XL Page Compressed. Let me pull that up here in Object Explorer just so you can see what that looks like. You'll see here we have a couple different versions of it. There's the original table, a test, a page compressed, and a CCI, hint, that's clustered column store. I've already created, so this is a row store table. If I go to properties and I go to storage, I can see right here that it says compression type page. So if it's a row store index with no compression, it says none. Otherwise, it says row or page or column. I've already created a non-clustered column store index on it. You'll see that syntax is the same. Let's run a couple queries against this to test the benefits of it. So I'm going to clear out anything that's in the buffer pool. I'm going to run a query with a couple of aggregations. And I'm going to use this option, ignore non-clustered column store index, just to be able to prove what the differences are. Carlos, this is going to run for a minute. So if there's a question that has popped up a couple times that seems popular, feel free to fire away. This would be a good spot.
Yeah, so a question we got was, can column store indexes and non-clustered indexes coexist?
Okay, great question. Yes, so you can have a clustered column, or let me say that, clustered column store and non-clustered row store can coexist. You cannot have a table that has both a clustered column store and a non-clustered column store. That doesn't exist yet. All right, so let's look at our execution plan here. You'll notice clustered index scan all the way over to our select statement, which has cost of 83. That's pretty significant. It's gone parallel because of that. If I look at my I/O, I see 87,468 logical reads, so a little bit high. Now, I'm going to run that same query. I'm going to clean out the buffer pool and run that with the non-clustered index. First off, notice that ran significantly faster. My execution plan, a little bit less complex. I've got a column store index scan here. The operator looks just a little bit different. And if I go over to, so a couple things to note here. When I zoom in, the storage will say column store, and execution mode says batch. So that was where I talked about where it's grouping multiple sets of rows together and passing them down the line to speed up processing. Here, if I look at my select statement, the overall cost has gone from 87 down to 3.2, much better. If I look at my statistics I/O output, wait, how is that even possible? No logical reads and no physical reads? Well, remember, column store is not stored on 8K pages. What you're going to see instead is that, or fact reseller spales compressed, here, no logical reads, physical reads, 0. You'll notice I'd had that segment word on my table or on my slide earlier. So 11 segments of this index were read. Again, by being able to group like data types together and read them together, it significantly improves query performance. The next demo I'm going to skip, it's merely a just showing some sizes, and I'd rather skip that and get on to some other goodies. I'm going to mention operational analytics, because this was a marketing term and you still see it in documentation, and people think it's another feature. But in all reality, if you hear the term operational analytics, what that really means is that it's an updatable, non-clustered column store index on top of a row store table or an in-memory table. So what does that mean? It means that your writes, those transactions, your truly OLTP system, is going to a row store index or an in-memory table, which is designed to handle inserts, updates, and deletes. And then your non-clustered column store index on top of that is handling the reads. This separates out the writes from the reads and meanwhile still has a very significantly smaller footprint on disk rather than row store index and row store non-clustered index. A common question I get, Does it remove the need for a data warehouse? Right? You're saying I can have my OLTP system and have non-clustered column store index on top of it, which is going to hold all this data significantly compressed and return things really fast. That's good if everything's in one database. But how many of your data warehousing systems have data that's all from one source? No. Typically, a true data warehouse is going to have multiple data sources. Data is loaded in at different times of the day or the week or the month from various sources, and we have systems in place to cleanse that data, make sure it's valid, and then push it into our fact and dimension tables. So while column store indexes can help run queries against our transactional databases, they don't fully replace data warehouses. All right, we've done our demos. So that's indexing. Indexing still doesn't solve every problem. Why? Because when we're writing anything, doing an insert, doing an update, doing a delete to a row store index or a column store index, we need to take locks and latches, which means that while we're writing to something, only one thing can ever write at a time, and we have to wait for that write to be done before we can read the data. So in SQL Server and all relational databases, we have this concept of isolation levels. Isolation levels determine to what degree a transaction is isolated from modifications made by other transactions. In a sense, isolation levels answer the question of, are dirty reads allowed? Are non-repeatable reads allowed? Are phantom reads allowed? Dirty reads being, can I read data that an uncommitted transaction has started? Non-repeatable reads being, if I try to read the data and then another transaction modifies it, and then I read it again within my transaction, will I get the same data? Phantom reads, can I read data within my own session that's been modified? A row that matches, a newly committed transaction is issued. For every isolation level, it says yes or no. We have really loose isolation levels all the way up to really strict isolation levels. So here are our isolation levels allowed in SQL Server. The loosest is the read uncommitted, which says you can do dirty reads, you can do non-repeatable reads, you can even do phantom reads. All the way down to serializable isolation level, which is really locked down. No dirty reads, no non-repeatable reads, no phantom reads. Every statement within every transaction is locked into itself. These are the kinds of things you might need in a banking system. Read uncommitted is something you might use on a web page where you have product reviews and you don't really, every customer doesn't really need to see everyone else's recently made isolation levels, or I'm sorry, transactions. The default for SQL Server is read committed, which means there are no dirty reads allowed. So you cannot read data from uncommitted transactions, but non-repeatable and phantom reads can't happen. Let's take a look at what this, we'll take a couple of examples of what this looks like. So say that we have this table for orders. We have the same one we looked at with our indexes where we have tracking ID, sales order ID, tracking number, and status. We're going to have a few different sessions involved in this. We'll have some as writers and some as readers. In the read committed default isolation level, what happens is that readers don't block other readers. If we have 2 select statements or 10 select statements running against the same row or the same page at the same time, it's all good. But until when a write comes in, a write is going to block all readers. They have to wait until that write is a committed transaction. It looks something like this on a timeline. Reader 1 comes in and says, I want to select these fields. These are its results. It gets the sales order ID and the current status. Then an update statement comes in we're going to modify order 43686, that same row, and set the status update. So now let's say another read comes in before that write is finished. We need it to see that new value of 5. So what will happen is that it will not read until this is committed. That's the order or the flow of things in read committed, the default in SQL Server. But that isn't always helpful. What if you have a table that gets just tons of writes and a lot of reads, and we don't always want to wait? Well, we can change things up. We can set an isolation level that allows our readers to read even when writes are happening, knowing that we can only ever write to one object at a time. The two options we have are read committed snapshot and snapshot isolation. A couple of differences. So read committed snapshot, or RCSI, is a database level setting. It's not a true ANSI standard isolation level. It's something we change at the database level, which means it affects every statement and every transaction within our database. So if you turn RCSI on at the database level, it's going to affect all statements run against that database. The benefit of this, there are no changes at the application level. So if you have maybe a third-party vendor application that you can't modify, or developers don't want to modify something, you can still use RCSI. In this case, or under this model, readers obviously don't block writers, but writers also don't block readers. What happens is that when a write happens, a snapshot of the data is taken. That's why it's called read committed snapshot. It takes a snapshot of the data as it existed at the start of the write statement, not the transaction, but the statement. So keep that in mind. How this looks, I think my slide's a little messed up. Yeah, this yellow box should be down here. I promise I did not do Green Bay Packer colors on purpose just because I am in Wisconsin. All right, we have this reader come in that wants to select the sales order ID and status. It gets the order ID and the status number that's currently in the table. Then the update comes in and wants to change that order's status. Well, what happens when a reader comes in? Well, look at that. In our tempDB database, we now have a version of that row of data. So you'll notice 101591 here and 101591 here. So a version of the data is put in tempDB as it was when this statement started, meaning when it started, the status was in 4, and here it is. So this read happens before this write commits, and it gets the status of that row when, as of the beginning of this statement. Then, as soon as this completes, the next read that would happen would show the updated value of 5, not 4. So read committed snapshot isolation doesn't require application changes, and it allows you to be able to read data that is being updated. Sounds really great and convenient, right? It does. Just a couple things to be aware of. It uses tempDB. You'll need to make sure you have enough space and a properly configured tempDB to handle that load. Remember, when you turn it on, it's in use immediately and for every statement in your database. And when it does create a version in tempDB, in addition to whatever columns you have taking up space, it also adds another 14 bytes of storage for that row versioning. Again, make sure you have tempDB properly configured, make sure it's big enough, make sure it's not going to run out of space. The other option you have is turning on Snapshot Isolation level. Snapshot is an ANSI standard. Snapshot is something that you can't just flip on and have it automatically apply to all transactions. What you would do is update the code itself. So in your transactions, either in the application code or in stored procedures, wherever that's being written, the developers have to put in set transaction isolation level snapshot. Now, what happens here is that when data is read by any statement in a transaction, it's the transactionally consistent version that existed at the start of the transaction. So read committed snapshot isolation, RCSI, is at statement level. Snapshot isolation level is at transaction level. Other than that, it works very similarly. We have our table, we have user database and tempDB. We run our query, that's a read, we get the current version of the row. We update the row, and a version of that is created in tempDB. When a read comes in before this transaction completes, it reads the data from tempDB, reading that transactionally consistent version of 4. So snapshot isolation is great if you have the ability to isolate things down to individual transaction levels. Developers want to put in that work, and you have that space in tempDB. Of course, that means you have to have those code changes and the space in tempDB. There are some really great blog posts out there about isolation levels and changing them. I have resources at the end of the presentation if you're interested in learning more. Isolation levels are a great way to allow you to, again, read data that's being written to, which is a common problem within OLTP databases. Now, without doing code changes, do we have another option? We do. Those of you using availability groups can take advantage and should take advantage of your readable secondary replicas. To level set, what are availability groups? Well, in this case, we have at least two servers. Oftentimes, availability groups are built out with more. They're really designed for high availability and disaster recovery under one feature. In this case, a very simple availability group has one primary server and one secondary server. I create multiple databases on the server, and I put 2 of those databases into an availability group. The difference here, we're probably used to hearing about failover cluster instances. Failover cluster instances provide high availability at the instance level, everything, databases, security, agent jobs, etc. Availability groups provide availability at the database level. So in this case, I have my databases. The data is replicated over to a secondary. It's synchronously replicated. Yeah, I can have automatic failover, right? Just a wealth of information that goes into setting up the availability group. What you're really concerned with when talking about using these for reporting workloads or read workloads is the listener. Applications connect to the listener. So again, those replicas, synchronous or asynchronous, automatic or manual failover, used for high availability, used for disaster recovery, and used to perform reads. So if we set up our availability group correctly, if we enable read requests on our secondary replicas, everything goes through our listener, and this is how requests are handled. Say that our application sends in a read, a select statement. It goes to the listener, and the listener directs that to the readable secondary. Now our application sends in another select statement. It goes to the listener. The listener directs that to the readable secondary. Now the application sends an insert. It first goes to the listener, and it knows that it is a write. So it will send that to the primary, commit it to the secondary, send acknowledgement back. As you can see, this really can help redirect heavy read workloads off to another dedicated server. And with SQL Server 2016, we got a really great addition to the feature set, something I had been hoping for a long time. Round robin reads to our secondaries. You could set up an availability group in 2012 or 2014, but if you had 2 or 3 or 4 readable secondaries, you kind of had to create your own essentially load balancer or use a load balancer to put read requests to more than one of them. It just didn't exist. But now in SQL Server 2016, we have round robin routing. There's a little bit of work for that. We do have to have a listener set up. Every replica has to have a read-only routing URL, and every replica has to have a routing list set up. But when you have that in place, it can be really powerful. And I have a script set up that will show you how to do that. I'll make sure that when I post my information that I list all of that. If I go into presentations, reporting, configure AG read-only routing, you'll see that I have put this into a script that will show you if you have, 3 server or a couple of different servers and you want to do round robin load balancing, these are all the steps you could take. You're saying, Jess, what are the drawbacks? There must be something. There are, of course. So we already talked about read-committed snapshot isolation, that database level setting that will use tempdb. Under the covers, that's how the reads work. Again, make sure that tempdb is large enough and properly configured on your secondary replicas. The only other things, availability groups are complicated. If you've ever worked with them, I'm sure that you know that. Read-only routing lists can be complicated. The biggest thing that I see is people assume that server 1 will always be the primary. So they set up a read-only routing list where if server 1 is primary, round robin the reads between servers 2, 3, and 4. But you have to take into account, what if server 2 becomes primary? In that case, on server 2, you have to set up a rule that says my round robin goes between servers 1, 3, and 4. Then on to server 3. If server 3 is primary, set up round robin between 1, 2, and 4, so on and so forth. There's no UI for it. We're going to be using T-SQL for all of it. And the biggest drawback that I see, we don't get the ability to create a separate set of indexes on the readable secondary to support reads. So in your on your primary, in your main OLTP database, you'll have to have your indexes for your OLTP and your indexes for your reads. We just don't have that ability yet. We do have the option to create a secondary set of statistics on the secondaries, but that's more of an advanced feature that I just don't have time to go into right now, unfortunately. So, looks like I managed to barrel through that almost in time. Just a few more things to talk about. Again, a summary. We do have multiple ways to read our transactional data for reporting and analytical purposes. Things that you're going to have to think about. How large is my data? Again, things like column store indexes are great, but not on smaller sets of data. Something like an availability group might be really great, but not if you have a 10 terabyte database, because now you need to store, if you have 3 replicas, you're storing 30 terabytes worth of space rather than 1. You have to consider your storage size available, both for your databases and your indexes, and now tempdb, if you choose to use a different isolation level. And again, what trade-offs are you willing to accept? Each of these items comes at a cost, just like any feature does. There's always some additional maintenance and administration to be done, but they have tons of benefits in the long run. So definitely consider using non-clustered row store indexes to narrow down how much data you're returning. Consider non-clustered column store indexes on either row store or in-memory tables to support that operational analytics feature set. For large tables that don't have frequent small inserts, updates, and deletes. For more data warehousing style tables, consider clustered column store indexes. To assist in databases where you have a lot of locking problems, while you wait, your reads are waiting for your writes, consider read committed snapshot isolation or snapshot isolation as different isolation levels. Or if you're using availability groups, look at taking advantage of readable secondaries, particularly in 2016 or greater, where you can take advantage of round robin between multiple secondaries. So as I mentioned, I have lots of resources available in my deck, some resources on column store indexes, some great reads on isolation levels. Klaus Aschenbrenner and Kendra Little are two SQL Server MVPs who probably know more, have probably forgotten more about isolation levels than I will ever know. So I definitely recommend their work. And an article on availability groups as well. All right, well, thank you for sticking with me again. I apologize for the technical delays. I'm sorry we didn't get to run all of the demos, but I will make sure that the slides and the demos are posted for you. Carlos, I'm willing to stick around for about 5 more minutes if we do have any quick questions to answer.
Yeah, no, thanks a lot, Jess. That was a lot of great information in a short amount of time, even shorter than usual. So, we do have a few questions. Seems like a lot of people have hung around. So why don't I throw a couple at you, and then
yep, I'm absolutely willing to do that.
Yeah, and I'll send the rest to you later. But somebody was asking, so since you covered 3 different topics, maybe I'll throw one question from each topic at you. You were talking about isolation levels. They asked about TempDB, and how do you know when you have enough space in TempDB to do it, or how would you know how much space you might need?
Okay. Knowing how much space in TempDB is a little bit tough to guess. You would have to understand, how many writes are being done versus how many reads and how those are overlapping. There are some good articles out there about using, of all tools in the world, perfmon, so Windows Performance Monitor. It includes counters for things like reads versus writes just on disk. You can tell how many you're doing, how long they're taking. So that would be a good starting point. Once you've set up RCSI or Snapshot, there are perfmon counters for measuring TempDB and your row version usage. So I take advantage of that. That's probably the biggest tool. We did recently introduce a new DMV, but not until SQL Server 2017. In SQL Server 2017, there's a DMV that lets you see current usage by each database version store in TempDB. I'll have to dig that up, but that's another option.
Okay, well, thanks a lot. Hey, somebody's asking, can you put back on the screen the resources for Column Store that you had up there for the links, I think, while we ask another question?
Sure.
Yeah, yeah, thanks a lot. Somebody's asking, does snapshot isolation cause a column to be added to the tables, which could cause massive fragmentation due to page splits that should be resolved?
Does it, I assume that they're asking, does that require that same 14 bytes that the RCSI does? And yes.
Yeah,
but that's
okay.
Yes. So be aware of that when you're considering implementing it.
Okay, and I guess that was the question about could that then put you kind of in a state of fragmentation, right? And I guess it could, right, if that's the case.
It could.
Yes. Okay.
It is something to be aware of.
Okay, now about the availability groups. For readable secondaries, when using a stored procedure call, does the listener have to send it to the primary because it might contain an insert?
Correct. So when that diagram that I showed of the listener is very simplified. It's not going through any of the internals. When statements are sent, they do touch the primary first, just in case there are any writes. If there are any, they are satisfied by the primary. If there are writes and reads in a transaction together, they are satisfied by the primary. If it is truly a read only, it is redirected to the secondary. So there's a lot of very complicated things in availability groups. As I mentioned, you can go and look up some information on that.
Okay, well, sounds good. And
Yeah.
I guess one more question, and I think this goes back maybe to the terminology of indexing. And somebody asked, aren't row store indexes only available for SQL 2016 or above, right? And maybe it was I know row store indexes are what I would call the original type of indexes,
Correct.
right?
Original indexes, what I would consider just regular clustered and non-clustered B-tree indexes, have been available probably since the beginning of SQL Server. Column store indexes, again, available starting in 2012 under limited support. Better in 2014, really hit their stride in 2016.
Okay, well, you know what? That's all the questions I have actually at this point. So I think we'll wrap it up
Great.
here. Okay.
Sounds like a great ending. Again, if you have additional questions, email me, tweet me, hit up my blog. I've got lots of stuff out there.
Thanks a lot, Jess, and we're looking forward to seeing you here in Denver in a couple of days.
Thanks for having me, Carlos. Have a great afternoon, everyone.
Thank you. You too.
Bye.
Bye.